For the first menu task of Portfolio 2, I solved Jessica's problems. For the first question, I was asked to solve if I had a ratio of 2 to 3 blue paint to yellow paint to make green paint, how much of each color of paint would I need to get 100 pails of green paint? It asks you to solve it using two different methods. So the first method I used was I added 2 plus 3 and got 5, and that told me that 2 pails of blue paint plus 3 pails of yellow paint would equal 5 pails of green paint. I knew I needed to get to 100, so I needed to figure out what times 5 got to 100, which I already knew was 20, and so I just wrote down 5 times 20 equals 100. That told me I needed to multiply 2 by 20 to get how many pails of blue paint, which equaled 40, and then 20 by 3 to get how many pails of yellow paint, which was 60. If you add 40 and 60 together, you get 100, and that's kind of how I double-checked my answer. The second method, I wrote an equation, and I wrote y equals 2x plus 3x. Since the ratio needed to be consistent, I put x behind the 2 and behind the 3, because if I messed up the ratio, then it would be the wrong answer at the end. So I will put y equals 100, and that tells me the green paint. And so I put 100 equals 2x plus 3x. Then I added the 2x and the 3x together and got 5x. So then I divided 100 by 5 and got the value of x, which is 20. So I plugged the 20 into the x's, and I got y equals 40 plus 60. The 40 represented the blue paint, and the 60 represented the yellow paint, and that would give me a total of 100. For the second problem, I was asked if a small aquarium holds 2/3 as much as a large aquarium, and the total was 250 gallons. How much would each aquarium hold? Sorry if you can hear my dog. So for the first method, I added 2 plus 3 for 5, and the 5 represented the whole, the 2 for the small aquarium, the 3 for the large. Since the total number of gallons they wanted me to find out was 250, I divided 250 by 5, which gave me 50. For the small aquarium, I multiplied 50 by 2 because 2 represented how much the small aquarium held compared to the large, and I got 100. And then for the large, I could have subtracted 100 from 250, but I decided to stay consistent, so I multiplied 3, which represented the large, by 50 and got 150. For the second method, I used the tape model, and so I wrote down a little tape and divided it into 3 parts for the large, and then the same sized ones by 2, but only 2 of them for the small. I knew that those 5s needed to be a total of 250, and once again I divided 250 by 5 and got 50. And then I filled out the little tapes evenly, because for that model they have to be even. And then I added them together. So for the large, I got 3 little blocks of 50, and I added those together, and I got 150. For the small, I had 2 blocks of 50, so I added those together and got 100. For the third problem, I was told I got 30 questions right on a test and scored 40. How many questions were on the test? For my first method, I put 30 over x. X represented the total number of questions on the test, which was unknown to me at that time. And then I equaled that to 0.4, because 0.4 is the same as 40%. I then multiplied both sides by x, and I was able to then cross out the x that was under 30, and then I on the other side I got 0.4 x. Then I divided both sides by 0.4, and that gave me the value of x, which was 75. So that told me that there are 75 problems on the test. The next method I used, I believe these are called like a percent table, something, I don't really remember. But what I did was I had on the top side I had the percents, and on the bottom the values that equal to those percents. So first I laid out 9, or I put every 10%, so 10, 20, 30, 40, 50, and so on. So I first filled in the 30, and I divided 30 by 2 and got 15. That gave me what 20% would be. And that's 50, so yeah, 20% equals 15 problems. Then I multiplied 30 by 2 and got 60. 40 times 2 is 80, so 80% would be 60 problems. Then I added 80 plus 20 to get to 100, which I found out earlier 20% is 50 problems. 80% is 60 problems. So that told me I needed to add 60 plus 15 and got 75. So there's 75 problems on the test. For the fourth problem, I was told that at a wedding, 3 times as many guests chose chicken as fish. If there was 160 guests, how many would get chicken and how many would get fish? That told me that for one guest that got chicken or fish, 3 guests would get chicken. So that told me there would be a whole of 4. I used the first method and used a tape measure. So I gave the fish 1 block because for 1 fish there's 3 chicken, and chicken 3 blocks, and I made that a total of 160 because that's how many guests I was asked to figure out. I divided 160 by 4 and got 40. So I put 40 in each block, because each block has to equal the same number, and then I added those together. The fish only had 1 block, so 40 people would have gotten fish, and then chicken, there was 3 blocks, and 40 plus 40 plus 40 is 120. The second method I used, I created a formula, y equals x plus 3x. The first x represents fish, and the 3x represents chicken. I set y equal to 160 and needed to figure out x, pretending I hadn't already done so. So the first thing I did was set 160 equal to x plus 3x. Then I added x plus 3x and got 4x, so 160 equals 4x. I then divided both sides by 4 and I got x equal to 40. Then I plugged the x into the original equation, and so I got y equals 40 plus 3 times 40. And so my final answer was y equals 40 plus 20. 40 represents the fish and 120 represents the chicken. For the fifth problem, I was told that 4/5 flour makes 2/3 cookies, and I was asked how much flour would I need to make a full batch of cookies. I didn't really know how to start this one at first, so what I did was I wanted to make it so there was 1/3 cookies, so I could just multiply that by 3 to get the flour. So I divided 2/3 by 2, and so I then had to multiply 2/3 by 1/2, and I got 2/6, which equals 1/3. I already knew that it would be 1/3, but I just kind of wanted to show the process. Then I did the same thing for 4/5, and once again I already knew it was going to be 2/5, but I wanted to show it. So 4/5 times 1/2 equals 4/10, and then you simplify that to 2/5. So that gave me that if there is 1/3 cookie, you would need 2/5 flour. So then I multiplied 2/5 times 3, so that's 2 over 5 times 3 over 1, and I got 6/5. So that told me, and then if I multiplied 1/3 by 3, then I'd get 1, or yeah. So then that told me that, so 1 batch of cookies, you need 6/5 flour. For the next method, I thought, well, maybe if I just make the 2/3 an easier number, I can solve it that way as well. So what I did was I multiplied 2/3 by 3, and I got 6/3, which then simplified is equal to 2. And since I multiplied the 2/3, I knew I needed to multiply the 4/5. So I multiplied 4/5 by 3, and I got 12 over 5. So then the next thing I did was divide the 2 by 2, so I could get 1 for the 1 batch of cookies. And since I divided 2 by 2, I need to divide 12/5 by 2. When I did that, I had to times 12/5 by 1/2, and I got 12/10, which reduced is, or simplified is, 6/5 flour. So that told me with one batch of cookies, I would need 6/5 flour. For the sixth problem, I was told that a dose of medicine is supposed to be 20 grams, and Gus only took 9 grams, and I needed to find out what percent he took. So for the first method, I just divided 9 by 20 and got 0.45, which then is 45%. I knew that 20 would be the whole, and I needed to find out the percent of the whole, which I know I just have to divide the small number by that to get it. The second method I did as if I didn't know that. So what I did was I was like, okay, well, I know percentages are out of 100, so I wanted to make sure that the denominator was 100. And so 20 times 5 is 100, so I knew I needed to multiply 9 times 5 as well, because what you do to the top or the bottom, you have to do to the top and vice versa. So I multiplied 9 by 5, and I got 45, and 20 by 5, and I got 100. And so 45 out of 100 is 45%. For the second menu task of Portfolio 2, I solved how many across. This problem was like the one we had already done in class, where you laid out the number of light green rods to figure out how many it took to get the width of the paper, and from there we would have to figure out how many the other rods would take to get across by using the ratios between the green rods and the rest of the rods. For that one, I multiplied the number of light greens I got by 3 because it took 3 whites to get to 1 light green, and I wanted to get the total number of whites. I wanted to solve this problem in a similar way, but a little different because I had already solved it using the whites. So the first one that I solved was dark green, and it takes 2 light green rods to get to 1 dark green. This told me that you only needed half the rods for dark green that you needed for light green because it's twice as big. So I divided 20, which was the amount of light green rods it took to get across the width of the table, and I divided by 2, which gave me 10, and that was the number of dark green rods it would take to get across the table. Next, I moved on to white. As I've already said, it takes 3 whites to get to 1 light green. So I multiplied 20 by 3, which gave me 60, and that told me the total number of whites it took to get across the table. From there I went to red, because 1 red is equal to 2 whites. So I knew I needed to divide 60 by 2 to get the reds, which gave me 30 reds. The next rod color I went to is purple. It takes 2 reds to get to 1 purple. So I knew I needed to divide 30, which was how many reds that it took to get across, by 2 to get the number of purple it would take, and I got 15. The next rod I moved to was the yellow rod. Since there was no other color that was half the size of yellow, I decided to use whites for this. And I know for 1 yellow, it takes 5 whites. So I divided 60, which is the total number of whites, by 5, which is how many times whites goes into yellow to get the number of yellow, and I got 12. So it takes 12 yellow rods to get across the table. The next color I went to was black, and once again there wasn't any rod that was half the size of black, so I used white. So it takes 7 whites to get to 1 black, so I divided 60 by 7, and I got 8.6. The next color I moved to is brown, and it takes 2 purple rods to get to 1 brown, and it took 15 purple rods to get across the table. So I divided 15 by 2 and got 7.5. The next color I moved to was blue. I found out that it takes 3 light green rods to get to 1 blue, and I double checked this by laying the light green rods on the blue rod. And so I knew I needed to divide 20 by 3 to get the total number of blue rods, which was 6.67. The last rod I did was orange, and I knew that it took 2 yellow to get to 1 orange. So I knew I needed to divide 12 by 2, which gave me 6. So it takes 6 orange rods to get across the table. And that is how I solved how many across. Alright, so for the third menu task in Portfolio 2, I solved Gabby Herndon and Andrew's problem. I don't know if I'm saying Herndon's name right, but that's how I'm going to be saying it. So the first thing I did was I copied down the chart so I didn't have to flip back between the two pages on my computer. And then I solved using each of their methods. So with Herndon, I solved his method to find out how much he'd have for 20. I got 50. For Gabby's, I used her method, and I got 62.5. And Andrew, I knew Herndon's wouldn't work, so I didn't try his. And I knew it wouldn't work because on Herndon's, 1 is equal to 2.5, and 2 is equal to 5, which is doubling, and that is what his method would be. But in Andrew's, 1 was equal to 5, or stage 1 would be equal to 5, and stage 2 would be equal to 7, and 5 plus 5 is 10, not 7. So I knew it wouldn't work. So I wanted to figure out what would work so Andrew could solve this problem. And another way I wanted to disprove that Andrew could use Herndon's was to find formulas, because if the formulas were different, then that would show that he couldn't use that. So for Herndon's, I got y equals 2.5x. So what I did was I had the value of x, so it was like 1, 2, so I had, so. Alright, for the third menu task in Portfolio 2, I solved Gabby Herndon and Andrew's problem. I don't know if that's how you say Herndon's name, but that's what I'm going to say it. So the first thing I did was I wrote down the charts on my paper, and I decided to solve Herndon's problem using his method. So I multiplied, or I doubled 10, so 10 would equal to 10 paces equals to 25 feet, so 20 paces would equal 50 feet. I used Gabby's method to solve how much 20 would be, so I added the number of feet for 6 and 4 and got 62.5. And then for Andrew's, I knew that his was not going to work with Herndon's method, so I just didn't solve his. And I knew that because for Herndon's, when the number of paces is 1, the number of feet is 2.5. When the number of paces is 2, the number of feet is 5, and it doubles. But with Andrew's, when the stage number is 1, the number of cubes is 5, and when the stage number is 2, the number of cubes is 7, and 5 plus 5 is 10, not 7. So I wanted to, 1, solve Andrew's problem, and 2, I wanted to be able to find the equations for both of them, and if those equations were not the same, then I knew that they wouldn't be the same method. Like it wouldn't work for Andrew's. So for Herndon's, I have y equals 2.5x, and I set x equal to 1, and I got 2.5. I set x equal to 2, and I got 5. And then I put x equal to 10, I got 25. And this is how I verified that my equation worked. I double checked it with his actual data. So I put x equals 20, so I got 2.5 times 20, and I got 50, which is also 25 times 2. For Andrew's, originally I had y equals 3x plus 2, and it worked for 1, so I would be 3 times 1 plus 2, and that equals 5, but once I did it for 2, it didn't work, because I got 2 times 3 is 6, plus 2 is 8, and I knew I needed 7, so I switched the numbers around, and so I have y equals 2x plus 3, and I put x equal to 1, so 2 times 1 plus 3 is 5, and then I did x equal to 2, 2 times 2 plus 3 is 7, and I did this for 6, so 2 times 6 is 12 plus 3 is 15, and so I set x equal to 20, so I had 2 times 20 plus 3, and I got 43. And then at the bottom of my paper, actually let's go back up there, I know the value is different for, like the equations are not the same. Y equals 2.5x and y equals 2x plus 3 are not the same, and so I knew that Andrew's would need a different method than what Herndon has. I found the Andrews by I looked at the difference between. First, I started with all the numbers, and then I was just like, I don't need this, so I just found the difference between 1 and 2, which is 2. So I knew the difference was I knew the difference would be 2 from every single one, like it would keep adding 2. So if someone didn't want to actually make an equation, they could have just added, from 2, add 2 to get 9 and 11, and then do that until they have all of their 20. That would be a lot of writing. So the next thing I did after I found Andrew's, I noticed I didn't actually answer the question on my paper. So I just said, no, in Herndon's example, you could find 2 by using 1. 1 equals 2.5. 2.5 plus 2.5 equals 5. This can be verified in Herndon's chart. Using this logic with Andrew's, I would have had 5. Stage 1 equals to 5 cubes. So I'd have 5 plus 5, which equals 10. And in Andrew's chart, the stage is number 2 is equal to 7, and 2 is not equal to 10, or 7 is not equal to 10. And so that just shows that that method did not work. So for the fourth menu task of Portfolio 2, I solved Statue of Liberty's nose. So it gave me that the Statue of Liberty's nose was 4 feet 6 inches, and I needed to figure out how long her arm was and how tall she was. So what I did was I first measured my nose, which was 2 inches. And then I measured my arm from shoulder to fingertip because that's what the problem asked for me to find from her. And that was 2 feet 5 inches. And then I found my height, and that was, I'm 5 foot and 3 inches. And then I wanted to make sure the numbers were in the same unit. So for her nose, I made it 54 inches, and I did that by multiplying 4 by 12 and adding 6. And then I did the same thing with my arm and height. I just multiplied the feet by 12 and then added the inches. So the first thing I wanted to find was the Statue of Liberty's arm. And how I did this was I put my nose over my arm, which was 2 over 29, and set that equal to 54 over x. The 54 represented the 54 inches that the Statue of Liberty's nose was, and x represented her arm. I figured if, like my ratio of my nose to my arm would be similar to her nose to her arm. And then I divided 54 by 2 and got 27 because I wanted to figure out what I needed to multiply my own, my nose and my arm, the 2 over 29 by, so I could get up to the Statue of Liberty. So what I did was I multiplied 2 over 29 by 27, and I got 54 over 783. That told me that her arm would be about 783 inches. So that would be equal to 65 feet and 3 inches. And I multiplied that, my own equation, by, sorry, I just got logged on my computer, so hopefully it's still going. So I multiplied it by my own ratio of my nose to arm, so hers would be proportionate to mine. So then I did the height, and so I once again put my nose over my height, so 2 over 63, and then I set that equal to 54 over x, and that represents the Statue of Liberty's nose over her height. And then since I already found what times 2 is equals 54, that's why I used my nose instead of my arm width. So I multiplied 2 over 63 by 27, and I got 54 over 1,701. Those 1,701 would be the height of the Statue of Liberty. and that is also equal to 101 feet and 9 inches. So then when I searched up, well, that's how I solved the problem using my own proportions. So then I actually looked up the actual Statue of Liberty's arm, and I got, well, it said 42, and then I had to add in the length of the hand, so that would be 42 plus 16, 0.5, or so it's 16 feet 5 inches, or 6 inches, I don't remember. It would be 58 and 5 inches. And so then I subtracted that from what I found, which I found would be 65, and I was about 10 feet, or not 10, 7 feet off. And I would say just, I don't think that's that big. And that just could be because like everybody's proportions might be a little bit different. And so if my proportions were closer to the Statue of Liberty's, then maybe it would be closer. But then for the height, her actual height was 305 feet, and I was 163 feet off. So I think that this just could be because when we look at the Statue of Liberty, we look at her kind of at it like a downward angle most of the time. And so they needed to, when they were building her, they needed to make sure she looked proportionate to us from that angle. And, I mean, every angle from flying and everything. So I think they made her so high so from when we're on the ground, it looks normal to us. But then I think maybe that like the top, like her face and her arms and stuff is kind of proportionate to a normal person, because people often didn't fly around the Statue of Liberty, so they would want that to look normal too. So I think it was just kind of an architecture kind of thing. That is why I was so off in the height. And that is how I solved Statue of Liberty's nose. For the fifth menu task of Portfolio 2, I decided to try to do a dessert task, and so I tried the 88 problem from 1875. It asked me if I divided or separated 88 into two different parts, what would they be if the parts had to be as 2/3 is to 4/5. So I knew that the ratio between the two parts needed to be the same ratio between 2/3 and 4/5. So what I did was I divided 2/3 and 4/5 by each other, and to find what their ratio was, and I got 10/12. And I divided 10 by 12, and I got 0.8333, just so I had a decimal representation of what the ratio would be as well. So the first thing I did was divided 88 by 10/12 to see if I would get kind of one of the parts, and I ended up getting 105.6, and that's way more than 88, so I knew that was not the right approach. The next thing I did was multiply 88 by 10/12, and I got 73.33. And I was like, okay, maybe that's a part, but I didn't think so. So then I subtracted 73.33 by 88, and I got 14.6. And then when I divided 14.6 by 73.33, I got 0.20. So I knew that wasn't right because it wasn't the same ratio as I had before. The next thing I did was I tried multiplying 2/3 by 88, and I got 58.66. So then I did the same thing with, I multiplied 88 times 4/5 to see if I could get another part, and it was 70, and I knew 58.66 plus 70 would be more than 88. Sorry, my cat's meowing for some reason. So the next thing I did was desk instructions, because I really wanted the numbers so I could at least know if I was on the right track. And so I started with one part of 44 and the other part of 44, because I knew that'd be a ratio of 1. And then I just kind of added 10 from one side from the other side. Just to, so like for the first side I'd do 54, and the next I'd do 34, and I took 10 from part 2 and gave it to part 1. And I did this until I got to 45 and 43, and I got to the ratio of 0.95. And so then I just started taking ones away. So I took 1 away from part 2, added it to part 1, and I did that until I got the ratio of 0.83. And the first part I got was 48, and the second part I got was 40. So I at least had the numbers that the 88 was supposed to be divided into. So I didn't really feel like I really understood it at this point. So I wanted to see if I could solve it through just algebra. And so I set 88 equal to x plus y, and I also set y over x because that would be representing the 3 or the 2/3 over the 5/4. So I knew it would be part 1 over, or part 2 over part 1. Anyway, so I set those equal to 83, and I multiplied both sides by x to get x out of the denominator. And so I got y equals 0.83x, and so I plugged that back into the original equation. So I had 88 equals x plus 0.83x, and I found the value of x that way. So I got 88 equals 1 and 83rd hundredths x, and I divided both sides by the 1.83, and I got x equals 48.08, and I rounded to the whole number, which is 48. So then I just subtracted 88 by 48 and got 40. I really didn't feel like I had a good understanding of this problem, so I wanted to try to solve it in other ways, and that's when I talked to you about like what I could do, because I had just solved it through algebra and guessing and checking. So I tried to solve it with easier numbers, or an example problem with easy numbers to try to relate it to this. So I did 2/3 of 90, and then I found out how much every part would be, which was 54 and 36. So I tried to do that again for this problem, and I was getting really messy numbers, and I got a whole of 22 over 15. And when I tried to work with it, I just like wasn't getting the right answer. I got 61 time. And it's just, I knew that wasn't the right answer. I tried to turn it into decimals because I'm generally better with decimals, and I got a whole of 1.46, and I still got 60. So then you told me to try to make those actual numbers better, and so when I tried it, it was just getting messier and messier. So I had 10 over 15 times 2, and then I just made ratio tables to try to find easier numbers, which I never really did. And then as I was doing this, it just kind of hit me that I could use reciprocal numbers, and I was really just kind of like, are you serious, Crystal? You didn't remember this? So eventually what I did was I multiplied 2/3 by 3/2, and I got 6 over 6, which is equal to 1, and then I multiplied 4/5 by 3/2 as well, because you have to do it to both sides, and I got 12 over 10, which is equal to 1 and 1/5. So then I multiplied 1 and 1 and 1/5 by 5, so I got 5 and 6. So then I knew that I would have 6 different, so for the first part I'd have 6 little things on my tape diagram, and then I would have 5, and I just filled both of those up. So, well, I added those together, and I got 11 for the whole, and then I divided 88 by 11 and got 8, which told me that there'd be 8 in every single one of the different parts. And so for the first part I got 48, and the second part I got 40.